So for this problem, we're trying to find the net force acting on the system. On this block, the only two forces are the force of gravity and the force of the spring, which is pushing up. These two forces are only acting in the y component. So the net force is the force of spring plus the force of gravity. The force of the spring is equal to the negative spring constant times the stretch. So this would be negative 8.7, that's what's given to you, and then x would be L final minus L initial. But before you plug this in, you're going to want to convert this to meters, and you're going to want to convert this to kilograms. So when you plug this in, you do the L final minus L initial. When you plug that into the calculator, you're going to get that the force of the spring is 0.696 newtons in the positive direction, because the spring is going to be pushing up on the block. And then you want to get the force of gravity, and that would be the mass times the g constant. And since this is taking place on Mars, we calculated this in the previous problem, and the gravity came out to this value. So you would plug in the mass of the block, which is 0.06 kilograms, times the force from gravity. And when you solve that, you get negative 0.22225 newtons. After that, you just add these two values together to get the net force in the y direction. And that value is 0.473475 newtons. And since they want it in vector form, there are no forces in the x direction. This is the value that's in the y direction. And there are no forces in the z direction. And that's the answer.